Woohoo! We are to look at the back of this Hi folks, and welcome to this very belated episode of The Art of Engineering. I'm home early from work today, not feeling very well, but I thought this is the opportunity to do a bit of filming and talk about the celebration that is the joy of oscillation. My VFO for my single tube CW transmitter is finally able to make that CW transmitter oscillate. So I've now got frequency agility. Now, once upon a time, in the deep and distant past, when people were using crystal locked rigs or rock bound rigs, we didn't have the frequency agility we all enjoy today. And quite often people would transmit on the frequency or one of the frequencies that they had. If they were lucky, they might have a handful of crystals. And they would then tune around to see if someone was answering them, because quite often the person answering was answering on a different frequency. Fast forward past that point in time, VFOs became way more common, and that practice of tuning around to see if someone's answering you is pretty much a thing of the dim and distant past. We can, of course, call on frequencies that are known as call frequencies, and that certainly increases your chances of making a contact. Now with the waterfall, the advent of the waterfall, quite often operating QRPP or QRP even is quite difficult because you don't make much of an impression on that waterfall, and people tend to look rather than listen. Anyways, that CW transmitter, my single tube CW transmitter, has gotten me very excited about building with tubes, and I'm certainly going to do a more complicated transmitter or transceiver in the future. But it's certainly been a huge amount of fun for me. So let's end this introduction here, head over to the test bench, have a look at how it's all going. Hopefully in this video, we'll get a QSO. Let's go. The warm glow of a vacuum tube teamed up with a digital VFO, which gives me the joy of oscillation. Hi folks, welcome back to the test bench. This is our tube transmitter and this is our digital VFO. And I have it plugged into a battery over here, and the digital VFO is on the 12-volt supply. This thing will run smaller crystals, and it will also run these FT243 crystals. This was a 6940 crystal, and I've reground this crystal. There's a video linked below of me regrinding this to get it up onto the 40 meter band. And what I love about this, of course, is that it's very nostalgic to have a rock-bound rig, and I'd like to operate it as such, but I would also like the versatility of being able to scoot around using a VFO. So at the moment, just to show you that it actually does work, if we get the bias set up correctly, there you go. You can see the blue light. So we know it's working, and we can see on the oscilloscope 2 volts per division. Let's just make sure that that is actually 2 volts. Yep, 2 volts per division. We've got about a 6 volt peak-to-peak signal. Reasonably sinusoidal. I am going to play around with that and try and make it better than that. But what's great about this arrangement presently that I have for the FT243 crystal is that it's running off this 3.5 millimeter stereo adapter. So what that means is I can get my output from my VFO and plug it in here as well. So that is the output from the VFO. And if I plug it in here, you will notice that our voltage drops down to about 3 volts. So we're losing more than half of the signal when we load the circuit down. So we need to find a way of making that signal a lot beefier than it presently is, because playing around with these settings here and the bias does not get us to the point where the thing is actually transmitting. Now, initially when I was plugging this in, I was getting no signal. It was killing the signal completely, and that is because, let me just quickly explain this. Initially what I was doing was I was running this 74LS175 chip, and this is a divide by 2 circuit that's using not the whole chip. So this pin here, pin number 1 has to be high for the thing to be on. So this is a way of turning on and off this divide circuit. So I feed 14 megahertz into the circuit, and that gives me 7 out. So when I want to have the VFO not interfering with my receiver, what I can do is I can switch off this 5 volts on pin 1, the high value on pin 1, and that'll mean that I'm no longer producing the divide by 2. Hopefully you're not going to be interfering too much with your receiver. It's a square wave, so there will be some noise, but we're hoping it's not going to be too noisy. So that was how I was going to do it, and I ended up feeding that into another circuit, which is, it's kind of like, well, I guess it's a Darlington pair, which is just here. And that was not getting me over the line. When I plugged this in, it was killing the oscillation. And that is probably because it's loading it down and we have impedance and problems and all that sort of stuff. So I tried using a circuit like this, which I didn't actually use this transformer. I just tried coupling. I had an RF choke in here to stop the RF from disappearing on the supply line, and I was trying to use a FET. It was an IRF 510. That didn't work well at all. Probably biased incorrectly and just, crappy circuit, not very well thought out. But then I started thinking, well, there might be other problems with this circuit. And of course, Tim, my Kiwi buddy, has been letting me know that these things here, this LS74, LS175, generates a tiny little current. It's not designed to be loaded down. So what I did next was I went and consulted the Oracle. Drew Diamond, Radio Projects for the Amateur, volume number 2. And this is where I got the divide by 2 idea, because he uses it a lot in his designs. Now in the transmitter designs in this volume, we have a 4-band CW QRP transmitter, CW transmitter right here. Now I'm going to show you the part of the circuit that I am playing around with. So what I ended up doing was, this is the divide by 2. It's a different chip to the one that I'm using. So that's already probably most likely problematic. But he uses a 74HC04 as a buffer. So it's inverter gates. It's several of them in the one chip. And what he does is he gets all of these inverters. There's 1, 2, 3, 4, 5, 6 of them in the chip. And we're using 6 of them in parallel. 6 of these inverters in parallel is hopefully going to provide enough drive. So that is what he's doing. I'm getting the output from this at about the same voltage. But what's happened now is he's putting this in an IRF 510 for the final stage. I could do that, perhaps, and I may do that, but I'm just trying to be a little bit different by using that Darlington pair that we've mentioned previously. But what I need to do first is check, because I have this sneaking suspicion that I'm running my Darlington pair off the 5-volt rail when I could be running it off the 13-volt rail and getting a much larger voltage swing. So let's check to see whether I'm actually right. Check that voltage. Let's have a look at how we'll put that pin there. Top of this 1K should be the voltage we're dealing with. It'd help if we're on DC. God, hopeless. That is 13.8. Okay, this is where I also got the buffer amplifier circuit that I'm using. A digital VFO for vintage transmitters, Greg Larter, and I've got a lot of the circuitry that I'm using, not all of it. Some of it, like I said, Drew Diamond's helped me out with. I like to do the Frankenstein monster approach. Now, this might not be the most reliable approach, but hey, it's fun to have a play. This is the Darlington pair buffer amplifier that I'm using, that's being fed by the Drew Diamond digital circuitry. And he says that sometimes this won't produce enough voltage for a tube transmitter. So what he's done to solve that problem is he's done this transformer that we've got here. There's a 1 to 2 voltage step up, so it'll step the voltage up. So what I've done is I've taken the core that I used to wide my 2.5 millihenry chokes. Probably overkill, but that's what we've taken.
and I'm assuming that it's going to be a reasonable core material. It's ferrite, it should be fine. And there is the capacitor as well, and the layout of the circuit. So we're going to take this coil that we've already wound, put the capacitor on, meter it out, get it all wired up. I will get back to you and tell you whether we've succeeded in getting our transmitter to transmit.
We are back on the test bench and working on the VFO for our single tube transmitter. And I will admit it's been a struggle. So you can see on the scope there, that is the output from the actual transistor that I've put in. Now, we were using a Darlington pair, I'll show you that, as indicated earlier in the video. But that Darlington pair, this transistor just kept blowing. Now, I think it's because I'm driving this circuit a lot harder that the digital VFO in the original design was actually putting out. So what have I done? Well, rather than spend time trying to work out biasing and all that good stuff, I've gone back to a trusty BD139 and played around with a pot to try and twiddle it to get it to actually amplify and look all right. And so we have, actually, you probably can't see it, but there's a little pot hanging off here. It's a 1 mega ohm pot, and believe it or not, to get this circuit to work, I had to wind that back till it was 1.5 or 2 ohms. So I'm going to get some low value resistors tomorrow to put into that circuit. I'm getting about 2 watts out. When I use a crystal, I can tweak this with the 243 FT243 crystal up to sometimes close to 4 watts, 3.5 or 4 watts. So not getting quite as much power. You will see if you listen. I'll just show you what happens on the and I will turn on the TS520 so you can actually hear it. So that is the 7 megahertz tone you can hear from the oscillator. And we're getting about a watt out, or a watt and a bit. Not a huge amount of power, but this has never been giving me massive amounts of power. I'm just happy that it's transmitting. And that tone that you can hear now, the idea with that is I have a pin on the divider circuit which takes our 14 megs down to 7 megs, and when I earth that pin 1 on that divider chip, we get rid of the division process, and that saves me from the noise from the VFO when I'm receiving. And there it is again. So in transmit, we're ready to go. As soon as we flick over to receive, the relay will switch this to an earth, and hopefully we will have the silence that we require to receive CW. So I'm very close to having this all going. And we may even try to team it up with our realistic solid state receiver, the DX160, which I did a video on when I did a bit of a restore on it. Failing that, we will go to the Discovery Air Spy over here. We'll see how we go. Fingers crossed. Now, my DX160 has a standby switch on it, and you can manually operate that switch. But there is also the provision at the back here to switch it with a relay. So the plan is to use the relay inside my 1-tube rig to also put the receiver into standby. That's the plan. We have our RCA connector here, which will marry with the rig. We need to find the right contacts inside the actual transmitter. At the moment it's not doing what it needs to do, but this will plug in there. And then I've got these RCA connectors which plug nicely into that socket at the back of the receiver, so that will get us into there. I don't have the necessary plug, so this will get us out of trouble. Solder that all together,
and we'll put some heat shrink on it and whatnot, and that'll hopefully give us an automatic standby whenever we flick the rig from receive to transmit. Incidentally, if you look at the rig in transmit, the divide by 2 circuits working as previously shown, going to standby, switches off the divide by 2, which means we won't be hearing it in the receiver.
Well, we have had the labeler out. I know where everything is on this rig, but you know, many years from now, when this operator is silent key, maybe this will turn up in a junk sale one day, and someone might be interested to know what each of the controls does. So in that eventuality, I have labeled, and of course down the track, I'm probably going to forget where everything is, especially if we are to look at the back of this thing, which one's the receiver, which one's the antenna, all that good stuff. So we've labeled that, and I have also labeled the actual connectors that go into the back of the receiver and the VFO, so we're not going to get those ones confused as well, because one is normally closed and one is normally open depending on transmit and receive. So let's pop over to the actual operating position, plug all this in, and see if it actually will work as a receiver transmitter combination.
Receiver, isolation, on receipt. Round, get it in position. Plug that in, so that's working. We'll find out if it's working in a moment.
Okay, the handmade key is going to be resurrected for this very homebrew situation, and very old school situation too. Well, let's see if it all does what it's supposed to. We'll go to dummy load. Power is on. We're in receive mode at the moment, and let's just see if we can hear the tone when we go to transmit in the receiver. We'll turn the volume back up again, and we'll tune and see if we can hear it. That's it, I think. Three, two, 9. Graham. He's asking me if it's QRP.
Woohoo!